In this example, we're going to make a sketch of the parametric curve that arises from plots of the coordinate functions when the coordinate functions are plotted against the parameter t. So we have a plot of the coordinate x versus the parameter t, and a plot of the coordinate y versus the parameter t. And we're going to plot the resulting parametric curve, of course, on the xy plane where parametric curves live. So the first thing that I do in these types of cases when I'm given plots of x and t, or x versus t, y versus t, is I want to discretize that curve into a collection of individual points. So more or less what I'm going to do then is plot the parametric curve point by point. So in order to do that, the first thing that I do just on the xy plane is I try to look for the minimum value in x, the max value in x, minimum value in y, and max value of y, just so I can make the appropriate tick marks on the xy plane. So in this case, the minimum value of x looks like -2, the max value of x looks like 3 for a parametric curve. Similarly, the minimum value for y looks like -2, and the max value of y looks like 2. So it looks like in any coordinate, the furthest we're going to go out in the xy plane is 3. So I'll make those tick marks now. All right, then the next thing that I do is I want to discretize these curves into a series of only individual points. So what that means is basically I'm going to take our parameter and I'm going to look for the same parameter values in each plot. So in other words, I'll take basically when t is 1, we're going to look at the xy points. When t is 2, we're going to look at those points, and similarly the same things. So I'm just going to mark basically on our curves where t equals 1, 2, 3, 4, 5, and so on are all on. All right. So now that I've figured out the same t values on each curve, basically what we can do is look at what their xy values are at each of those points. So when t is 0, our x value looks like -2. And when t is 0, our y value, actually that also looks like -2. So on our plot in the xy plane of the parametric curve, we can just put that point, -2, 2. That's basically where our curve starts. And we can do this for all the points that we've marked off at all these same t values. The t values don't have to be 1, 2, 3, 4, etc. We just have to make sure that we're grabbing the same x value and y value at the same t values. So let's go ahead and do this for some other points. When t is 1, it looks like our x value is still approximately -2. And when t is 1, it looks like our y value, though, is now approximately +2. Okay, so if we plotted that on the xy plane, we would be at -2 in terms of x, so somewhere along here, and we're at now a positive value of 2 for y, so it looks like we are there. And if we wanted to, we could connect those points with some curve. And granted, I'm drawing a straight line because I'm basically saying, you know what? I'm not looking at any x values or at times between t equals 0, t equals 1. So the best I can do is sort of connect straight lines between everything in the same way with y. All right, so let's go through this curve and just fill in some of these other points. When t is 2, our x value is approximately 1. When t is 3, our x value is still approximately 1. When t is 4, our x value is now approximately 3. When t is 5, our x value looks like, I guess, approximately 2. When t is 6, our x value is approximately equal to 3. And finally, when t is 7, our x value looks like it's approximately 1. And we can do the same process for all the y values. When t is 2, y is approximately minus 2. When t is 3, y is back to being approximately 2. And same thing when t is 4, our y is still approximately just 2. When t is 5, our y is now 0. When t is 6, our y is back to being approximately minus 2. And when t is 7, our y is still approximately minus 2. So let's go ahead and just grab these points. So first, looking at what happens when t is 1, our x value looks like minus 2. Our y value, it looks like 2. Again, that is the point that we plotted earlier. All right, so going to the next point, when t is 2, our x value looks like 1, and our y value looks like minus 2. So going when t is 2, we go over to x equals 1, so somewhere along this line, and y is minus 2. So that puts us down here. And again, we can connect those points using a straight line. Oops. Just because we don't have any t values in between those 2 points. Next, when t is 3, our x value stays at approximately 1, but our y value looks like it grows up to 2 now. So when t is equal to 3, our x value is 1, so we're along that same line, and y is 2. So it looks like we are up here. We can connect those again with the straight line, just because we don't have any t value information between those points right now. All right, so when t is 4, our x value looks like 3, and our y value, it now looks like 2. So when t is 4, we're about at x equals 3, and we are at y is about 2. So it looks like we are around here. So again, connect with the straight line. All right, so next we can keep moseying on along. When t is 5, we're approximately at x is 2. And when t is 5, we're approximately at y is 0. So let's go back to that. So x will be at about 2. So somewhere along this line, and y is now 0. So we are at about 2, 0. And we can connect that with a straight line. Again, these lines wouldn't be straight if we had filled in more t values between these ones that we've done so far. So next, when t is equal to 6, our x value, it's back to being about 3. And when t is 6, our y value is about minus 2. So we're at x equals 3, so somewhere along this line, except we're told y is minus 2, so we are back down here. And again, we can connect those points along our curve, just kind of see where we're headed here. And finally, going to the last point now, we're at t is 7, x is about 1, and when t is 7, our y value is still minus 2. So what that means, we're back at x equals 1, so we are back at that same point from earlier. So this is what our parametric curve looks like. So let me just go ahead and trace this out really quickly. So it looks like, again, we start at this point that's about x is minus 2 and y is minus 2. We move upwards. We move to the right and downwards. We move almost straight upwards. We move to the right with little vertical motion. We move a little to the left and downwards. We move a little to the right and downwards some more. And then finally, it looks like we move just about to the left with little vertical motion. So we can also plot the direction of this curve. Since this is a parametric curve after all, we have a particular direction, and that direction goes in terms of the increasing parameter values. And the last thing I'll just say, the more points that we choose, as in the more t values that we choose from our X versus T and Y versus T plots, the better accuracy we can get in terms of the actual parametric curve that is represented by those two individual coordinate plots.